Now, I was intrigued as a kid. I saw a map of the surface of the tongue. It said, here is sweet, here is sour, salty.
That's BS. Tell the truth.
Unfortunately,
That's got to be BS.
the map is a fiction.
This is StarTalk, special edition. Got with me my usual co-host, Gary O'Reilly. Gary.
Hi, Neil.
Hey, former soccer pro turned soccer announcer, and we get to share you with the soccer universe. Thanks for being part of the StarTalk family. And of course, Chuck, nice, Chucky baby.
Hey, what's happening?
Gary, you and your producers put this together. So give me the setup for this.
Okay, so I suppose we all do it. We all eat.
You think? Yeah, okay.
Our bodies need fuel. We shovel it in and we burn it up.
Into your pie hole.
Yep, in the pie hole. Then it goes. But how many of us stop to consider the fundamentals of what we eat, such as flavor? Is it luck? Some meals taste better than others, or are we being cleverly led into a foodie heaven? Then ask yourself, why do some foods work better than others? And whose idea was it to put sea salt on caramel? Really, whose idea was that? Because it works really, really well, but it wouldn't come straight to your mind unless somebody gave it to you. So then you go, is cooking just cooking, or are we looking at science here?
I'm going to guess it's always science. That's what I'm going to guess. That's
All right, then. There's you out on a limb again, Neil.
So we've got with us repeat guests. This might be your third time on StarTalk, scattered over 5 or 6 years. Arielle Johnson. Arielle, welcome back to StarTalk.
Thanks so much for having me back.
You have the coolest designation as a flavor scientist. That's a thing.
Flavor.
It's a niche field, but we're passionate about it.
Okay, you are the flavor scientist. That's how niche-y it is. You're advisor to some of the world's top chefs, top restaurants. You have a PhD from none other than UC Davis, which has I know about their wine division, but they also have a food division there?
They do. I was actually in the wine department because they have a really strong experience with the science of flavor.
So do I.
Yeah.
But that's enology, isn't it? That's
Yeah, viticulture and enology. Yeah.
And you're co-founder of the Fermentation Lab, which sounds a little weird. It's better than the Fomentation Lab, I guess. And what does it have to do with that world-renowned restaurant in Copenhagen called Noma?
Noma.
So Noma started with, in retrospect, a little bit of a stupidly difficult creative constraint, which was let's cook with ingredients only from Scandinavia.
Oh, God.
Which, yeah.
Yeah. And I mean, seriously, and we're celebrating this place? Come on.
Yeah, potatoes, beets, onions.
Let's just get real. Like
Cabbage.
Right,
Yeah,
exactly.
Exactly.
This Noma restaurant is world famous, possibly even across the galaxy. And I know people, they are people with means, who said, this weekend, let's go eat out at Noma. And they chartered a plane and flew there just for that. So this has got to have some remarkable draw upon people's taste buds. So what was your relationship with that restaurant? Remind us.
So when I was in grad school studying flavor chemistry, I went to grad school because I was really passionate about food and wanted to, be a scientist that was working with chefs and restaurants and applying that. Noma was a place that had started their own Nordic food lab to study ingredients and flavor, and were working with techniques like fermentation and wild ingredients, and just was sort of everything, that I wanted to be doing. So I kind of talked my way into an internship in their initial lab and really hit it off with everybody. And
You just talked your way in.
A little bit, yeah.
Okay. Very cool.
Great.
I think they were a little skeptical, but after, some light hazing, a couple of, cases of rhubarb to juice to see if I would do it. It turns out that, they're sort of deep thinking about flavor and how to find it and how to work with ingredients. And my knowledge of, food chemistry was really complementary. And
you're also the science officer, that even such a thing, on Alton Brown's TV show, Good Eats.
Yes. Yeah.
Well, just to remind people, we had both of you on stage at the same time for a StarTalk Live wasn't it the Beacon Theater? I think it was.
The town hall here in Midtown.
Okay.
Yeah.
And it was some years ago. So we've been exposed to you before. Is that relationship still exist?
Good Eats isn't in production right now, but Alton was actually kind enough to come and do my initial book launch event here in New York at Rizzoli Bookstore. So
Is that the Flavorama book?
that is the Flavorama book. I have it. This is the book
Oh my
that I
God.
wrote.
That's cool.
And when did it come out?
This came out in March, so it's been about 3 months.
March 2024. And subtitle, A Guide to Unlocking the Art and Science of Flavor. Can't argue with that. I mean, come on now.
No, yeah, everybody loves flavor.
Right.
Yeah, they do. They do.
Everybody loves flavor.
Tell me, are you helping to create meals for a Michelin star restaurant so that they keep their star? Or did they not previously have a star?
Until
And
you
because of
arrived.
that kind of investment, they then earn one or more of their Michelin stars.
We need another star. Go get Arielle.
Well, I don't think about things like Michelin stars, but it's the kind of thing where a place like Noma is constantly, pushing the boundaries and trying to kind of not rest on the laurels and find ways of, being more creative, coming up with new ideas. And turns out science is really helpful for that. So I don't feel like I can take any credit for whatever, awards or stars, but I do know we work well together and make some tasty stuff.
So are there some fundamentals, Arielle, to your sort of view on flavor, or actually the way flavor exists and how we experience it?
Or is it as simple as salt?
It often is, but not always. So, going back, we agree, everyone loves flavor, and they do. It turns out that everyone loves flavor, but no one really understands what it is or how it works. But fortunately, in the sciences, we do actually know that information just hasn't crossed over.
Crossed over, I like that. Because the science of the rest of the world, has it crossed over? I don't know. But
Yeah, well,
scientists are up on it. Yeah.
the walled academic garden. Yeah, so the first things I like to kind of bring people up to speed on is that flavor is molecules. So, everything that you experience as a flavor started as a molecule that binds with one of your many receptors. Flavor is an experience created by your brain. Flavor is mostly the senses of taste and smell, and those are our two chemical senses. So whereas vision is sensing light, and hearing senses pressure, vibrations through the air.
We call that sound, by the way.
Yeah, but that is what. But is it sound until your brain interprets the signal into sound? Is it just waves through the air?
Yeah, philosophers like distracting themselves with that question.
Yeah.
So there's a difference, Arielle, is there not, between orthonasal olfaction and retronasal olfaction?
Yes.
And I'm not quite sure I know the difference, but you will, won't you?
Okay. Yeah, I do, fortunately. So flavor is taste and smell. Most people understand that flavor is taste because all of flavor feels like taste. It's, happening in your mouth. When I tell people that flavor is also smell, and in fact that smell is like probably a larger part of flavor than taste, that's kind of a hard sell for people.
I thought people knew that if you hold your nose, you don't taste your food. We won't do that as an experiment.
Some people know. Yeah, no, and it's a good experiment, especially now that more people have had COVID.
I was going to say a better analogy is to have a cold.
Exactly.
Just think how you feel about food when you have a cold. And the reason is that normally you can't smell things, and so food isn't nearly as appealing.
Yeah, so as like flat tasting as food is, that is actually flavor with only taste, flavor without smell. Without smell, tastes themselves are very flat. So yeah, the tricky way that smell is a part of flavor. So first off, while we're eating, our brain tricks us. We experience smell, but it doesn't feel like smell. It doesn't feel like it's happening in our nose. We'll be perceiving smells in our nose, but it's a pretty famous psychological illusion, actually, that that sensation gets kind of moved so that you perceive it as happening inside your mouth. So if you were to take a jelly bean and chew on it with your nose closed like that, and then open your mouth, you'll feel like the kind of fruity flavors of the jelly bean bloom on your tongue. It's actually happening in your nose, but it's sort of translocated in your brain to the mouth.
The brain just never telling us the
Your
truth.
brain is always a liar.
Yeah. Well, I think it's important to know, what's perception, what's reality, how are the two related. Big fan of that. I mean, the other thing is when you say smell, most people think like sniffing. So like, oh, you have a plate of food and there's smells coming out of it, and I guess you sniff it before you chew it. I mean, you do, but yes, there's actually two types of smell, two types of olfaction, as Gary mentioned. Sniffing is orthonasal olfaction, so it's ortho because it's normal forward, the front of the nose. But since your nasal passages in your throat is basically just a tube, air can go in through the nostrils, but air can also travel from your lungs out. And so while you're chewing your food, it's full of volatile molecules that are able to float through the air, and they just sort of float up the back of your throat.
Normally, when we think of the word volatile, we think of something that would ignite into flames or a person who is otherwise unstable. But I think when a chemist uses the term, they're just referring to molecules that will readily evaporate from wherever they were.
Yeah, so molecules that are kind of light and then sticky enough to be gaseous some of the time. But retronasal olfaction. Every time you have food in your mouth, every time you're chewing, every time you're swallowing, you get these little puffs of sort of scented air that go up the back of your throat and into your nose. And those volatile molecules can bind with your olfactory receptors, and then you're smelling as you're chewing.
Now, I was intrigued as a kid. I saw a map of the surface of the tongue and where it said here is sweet, here's sour, salty, whatever. Was that just...
that's BS. Come on, tell the truth.
Unfortunately,
that's got to be BS.
There we go. Yes. So unfortunately, the map is a fiction. You don't have many taste buds in the center of your tongue.
So the only thing I could conclude was that if I put flavors in the center of my tongue, I did not taste it. I found that to be so.
Taste buds are like much more concentrated along the kind of edges and tip of the tongue.
Okay. So I wasn't entirely misled by it.
No. But unfortunately, it's not quite as tidy as having like the sour area.
Because it was like way
area.
tidier. I said evolution is not this tidy.
It kind of makes sense when you look at the construction of your mouth and eating. So along the edges is where you chew. And the first taste comes in through the front of your mouth. So that's the tip of your tongue. So it would make sense that that's where you would want to stimulate taste the most.
I got a good one for you. I forgot what two cities I was between when I was giving a public talks. And I had a driver, and her name was Taylor. I think if I'm remembering that correctly. We had a whole chat about all kinds of things. And she used to work for FedEx, but then drove trucks. And then like big trucks, and now she became a driver, like a car service driver. So and she knew I was a scientist. We just started talking sciencey things. And she said she made a discovery. And I said, and she told me the discovery. It's like, whoa, I'm going to try that. So here's her discovery. She eats her hamburgers upside down.
You mean hanging upside down like a bat?
No. I don't think that's what she meant. If you invert the hamburger and you bite it, all of the toppings you put on the pickle, the ketchup, the cheese, that hits your tongue sooner than it otherwise would if it were face up. And it made sense to hear it, but then I tested it. It's like, yes. I don't have to keep swishing around the food to get to my tongue.
See, I have a better way of doing that because this is how I do it. I just put all the condiments on both buns.
Both sides.
Both sides. Like the sauteed onions, I put them on top and bottom.
Ketchup, 2 slices of cheese. That'll work.
Everything.
True innovation. Yeah.
Yeah. And now the only thing that I don't do is 2 slices of cheese, top and bottom. So maybe I'll try that. Yeah.
That sounds good.
I'm just wondering a couple of things. Is a big part of what you do, I think this is what drives modern chefdom, is not just what a flavor is, but what a melange of flavors might be, and what insights you might have in combining those flavors to come up with something transcendental.
A lot of restaurants now are much more like seasonally driven and are interested in things like local produce and things that peak and change with the seasons, and figuring out the best way to kind of express the flavors of all those ingredients and put them together.
I thought it was odd first time I ate at a Chinese restaurant, and there were food items called sweet and sour or hot and sour, sweet and sour. When I'm thinking to myself, do I really want sour with my sweet? And why are they putting something that burns my tongue in the middle of the honey? Why is there hot honey? Like, who thought this stuff up?
Well, I mean, it's interesting because Chinese cuisine is really like the oldest continuously developing cuisine. I mean, there's like recipes that are 6,000 years old that are from ancient China that are still good.
Still good, really? Like,
I mean, yeah, they're like much more advanced than what people in Europe was cooking 6,000 years ago.
I was going to say they're still in use. It doesn't necessarily mean they're good.
Thank you. Let's clarify that.
Because
So Arielle, is there like a color wheel for flavors where, when you're matching things that, the sweet will go with the sour because it sort of lines up in the spectrum?
I like that question.
Yeah, like yes and no. I mean, a lot of other flavor scientists have spent time kind of building wheels like that. There's the wine aroma wheel was one of the first ones.
Yeah.
Out of UC Davis. Yeah, I mean, it's tricky because flavor is so multidimensional. I mean, color, depending on how you look at it, has like 3 or 4 dimensions, or can be sort of expressed that way.
I mean, like there's brightness, there's hue, there's
exactly. So yeah, or like cyan, magenta, yellow, and black. There's like several different ways of expressing it. With flavor, we have 5 tastes: sweet, sour, salty, bitter, umami.
Tell me about umami, because none of us grew up with umami. Umami somebody just showed up at the doorstep.
Yeah.
And then everyone goes, this has umami. This has umami. It's like, what the hell is umami?
Umami is like the most recently identified of the tastes. You can go back to like classical antiquity and find the Greeks writing about sweet and sour and salty and bitter. Umami, chemically speaking, it's the taste of glutamate, which is the ion form of glutamic acid, one of the 20 amino acids that are in all of our proteins. It's a savory taste. It's a kind of mouth-filling, brothy savoriness.
Didn't we just call that savory though? Like back in the day, we just called that savory.
Well, so did umami bump out the word savory from the vocabulary?
Well, yeah, I basically, whoever discovers something first gets to name it. So, we had a concept of savory, but it wasn't until the early 20th century that a Japanese chemist, Dr. Kikune Ikeda at the University of Tokyo, he was studying seaweed broths. So in Japanese cuisine, they cook a lot with kelp called konbu. It's very savory tasting.
Is kelp the same as seaweed? I mean, are they considered the same food?
Kelp is a type of seaweed.
Okay.
There are, there are brown seaweeds, red seaweeds, various macro algae, things like that. But kelp is a particular type. So konbu, it's actually like a very it's like one very long blade or leaf.
We've all seen kelp forests underwater.
Exactly. Exactly.
I think it was even in Finding Nemo. So that meant it's really...
It's legit. Yeah.
It's legit.
So he was studying these broths and sort of concentrating them down until he eventually purified the savory component in them, which was glutamate. So he identified it as glutamate and then, called the sensation of pure glutamate umami, which comes from umai and mi, which means delicious flavor, delicious taste in Japanese.
Oh, I thought it'd be something deeper than that.
Yeah, so that was around the turn of the century, but it took about another 80 or 90 years to actually find the taste receptor for umami. So there was some controversy throughout the 20th century
as to whether it really existed.
Is umami a real taste? Does it just enhance other tastes? What is it? But then we know what the umami receptor is. It's been well characterized, so it's kind of now officially enshrined as one of the basic tastes.
Wow, that's fascinating.
As you've discussed with us just now, you've mentioned the ancient Greeks, you've mentioned the Japanese. If you had the same plant, same protein in Japan, would it have exactly the same flavor were it in Eastern Europe around the Mediterranean? Or is there some way that's varied the flavors that come out of?
Well, are you talking about a variation in the plant or a variation in regional taste buds?
In the flavor itself, will the environment and then maybe the food chain that's involved, if it was a predator, would that change? I
guess there's 2 ways of looking at this. One, if you drink wine, they talk about the concept of terroir, which is kind of, sometimes it's described to just like the taste of the rocks and the soil, which isn't really how it works, but it is like the taste of place. So, they have a lot of clones of grapes. There's Pinot Noir clones that are genetically identical. And if you grow it in the Sonoma Valley versus in, New Zealand, they're going to taste different, even though they're genetically identical. Yeah. So phenotype, the way that an organism, appears in his constituent.
I'm going to add to that, Arielle, since you hung out at UC Davis.
Sure.
Maybe there's something about this. I like French wines more than I like Italian wines, but there was nothing greater than the taste of an Italian wine, a Tuscan Italian wine that I had in Italy, in Tuscany, on a ravine, overlook. I mean, just that wine.
That was psychological, man. You were sitting there like, damn, I spent a lot of money to be here.
This better be worth it.
Exactly.
Basically, the composition of any organism, chemically, biologically, is going to be an interaction of its environment and its genes. So growing the same plant or, animal or whatever in two different locations will make it chemically different depending on how it responds, and then it'll taste different.
Okay.
If you had exactly the same fruit, two of the same fruit that you cloned, well, not cloned, but like replicated, so they were chemically and biologically identical. And
at Star Trek, they use the replicator.
Exactly. In two different locations, two different people with different experiences with food wouldn't necessarily have the same eating experience of them. We use our sense of flavor to kind of figure out what to eat, to not die, but also to fuel ourselves and hopefully increase our quality of life. So we use both taste and smell to help us with that, but we'll use like any context cues that we can find to figure out if this thing that I might be eating, is it a good idea or is it a bad idea? And so we're actually wired to kind of build up a bank of those memories and experiences and kind of pull them up the next time we taste something and be like, okay, have I tasted this before? Did I have a good time? Did I have a bad time? Do any of you guys like root beer? Do you drink root beer?
I used to, like when I was a kid. Yeah.
Garrett, yeah. So root beer is a very American drink. It's got kind of herbal flavors with some kind of wintergreen kind of stuff going on.
Yes.
In Europe, they don't really use those flavors for food.
No.
In fact, that kind of root beery scent flavor is most prominently used in bathroom cleaning products.
And that's why we don't drink bleach here. I mean,
Right.
unless you're listening to a certain former president who knows how to cure a certain kind of disease.
Please don't do that. But yeah, no, I have European friends that have come to America and tried root beer, and they're like, "This is absolutely disgusting. This tastes like a toilet. Like, why would you drink this?"
There's an antiseptic ointment.
Okay.
Tastes exactly like root beer, which is
Amazing. Good to know.
Yeah, you're tasting your ointment.
No, it smells. Smell is very much the case. Yeah.
So you've experienced that, aroma experience before, but not in a food context. It's in a very much not like a non-food context.
Yeah.
So it's possible to like override that by exposing yourself repeatedly to a new flavor in a food way, but without deliberately doing that, people are going to have bring different experiences to their immediate surroundings and interpret flavor differently.
So cool.
Okay, so now we all agree, I think, in spite of the raw food movement, that most of us like our food cooked. Not only does it change the texture, but flavors rise up in ways that were not there with the food remained uncooked. So when I think of heat, I think of breaking apart molecules, not bringing them together. So are there complex molecules in uncooked food that somehow manifest flavors once the molecules break apart?
Oh, yeah. I mean, I guess a chemist would think of heat as like molecules moving around faster. So, when they move faster and collide, they can break apart, but they can also kind of stick together. It's like if you threw a bunch of Legos in a clothes dryer and let it go. If you had a Lego figurine.
At the end, you have a pie.
But they do stick together.
At the end, you have Megatron.
Exactly. Or something less ordered but stuck together in a different way. So yeah, I mean, like if you think of like a steak, as you cook it, first you'll get reactions between the oxygen carrying molecules in the muscle, the heme and the myoglobin. There's like a little iron atom, and iron is quite reactive. That will react with some of the cell membrane lipids in the cells and create that kind of like cooked beef flavor. And then as you continue heating up the outside, you'll start to generate reactions between sugars and amino acids. There's like trace amounts of both in the kind of, meat juices, essentially. And that will create the Maillard reaction, which is a lot of people's favorite food chemical reaction because it creates the flavor of well-seared steak, but also chocolate, roasted coffee, toast, brown butter, butterscotch, things like that. So any kind of delicious, toasty, nutty, brown flavor comes from that Maillard reaction.
I did a lot of cooking in my life, and I would say 1 out of 20 times something happens by accident. And of those accidental times, maybe 1 in 10 of those is, hey. And so how much of what we count as cuisine really came about by accident? Somebody made a mistake, or somebody was missing an ingredient and they had to grab something else off the shelf and invented an entire new taste experience.
Yeah, no, I think a lot of it comes from that, both from from messing up, from adapting to straightened circumstances where you can't cook what you know how to cook, and also I guess just the right proportion of weirdos that like to mess around with things on
Right.
purpose.
Well, now I'm wondering about your PhD. Who's like, was that just you just walked into a kitchen and made stuff up?
I guess I like to think of it as like guided making stuff up.
Okay.
Organized chaos.
Organized
like
chaos.
soccer.
That's the best word.
So
That's the best.
when you make a reduction in a sauce, why do the flavors become that much more concentrated?
Gary, you're evaporating out the water, and water's got no flavor. So,
Exactly.
So what?
I didn't ask you.
You're a hard question.
I didn't ask you, did I? I wanted to know from me.
In the UK, they don't reduce sauces. That's only in France.
Yeah.
So you're stuck with your watery liquid gravies. Is that what's going on?
Possibly.
But yeah, while you're reducing, you are evaporating water, and so the taste molecules specifically, taste molecules aren't volatile. You'd have to put them under like an insane vacuum to make them evaporate, so they get more and more concentrated.
Just so that our audience knows, the less air pressure there is on the surface of anything, but let's say liquids, the less air pressure, the more likely the molecules of that liquid, whatever it is, will jump off the surface and go into the air. So you use the term, in a vacuum, you could possibly evaporate some of these molecules, but at normal air pressure, you're not.
Yeah.
Right. Okay. So I just want to make sure everybody was understood.
Yeah. And I mean, and interestingly, this practice of creating a vacuum to evaporate things at lower temperatures, a lot of bars and restaurants use that now in the form of a rotary evaporator. So they're able to distill things at 30 degrees Celsius instead of boiling.
Well, how about sous videing? And I mean, that's low temperature cooking too. Without the vacuum, it's just a closed environment that you put whatever it is that you're cooking.
Yeah, you'll use like a vacuum chamber to basically like shrink wrap a piece of meat or whatever else you're cooking. So that then when you put it in a temperature controlled water bath, you get good contact with the entire
last time I sous vide, I didn't have a vacuum chamber, but I accomplished the same thing.
Plastic bag.
Yeah, a plastic bag.
Plastic bag, yeah.
A sturdy plastic bag. If you submerge it, all the water in the plastic bag wants to get out.
Yeah.
Because it wants to float up. So you just have a little straw hole in it. And as you lower it, the bag looks like it shrinks down on the food. Then you seal it, and I have basically a vacuum packed bag.
Yeah, no, it's a handy trick for if you don't have a vacuum sealer or yours is broken. I've done it before.
It's pretty cool.
And it works really well. It's like,
it works really well.
You look at it, it's as though it had been vacuum sealed.
Right. Yeah.
So there's a case, getting back to Chuck's point, we're not cooking it at high temperature. And so sous vide, especially meats, has become quite the rage in recent months and years. So who said, let's not sear it and still cook it? So, no, I know what it is. They still sear it only after they sous vide it.
Yeah, that's it.
Exactly.
And that's what happens. But but I got to tell you, when you do that, it's like you're sealing in all the flavor with the sear.
And it sears very quickly.
Very quickly.
It's
That's the other thing too. It's like
it's already almost at the right temperature.
Yeah, it's already. It's almost like you pre-cooked it. Really, that's all it is.
That's what it is.
I mean, quite literally, yeah. No.
You can't do the red meat at 130 degrees and say, "Here's your steak." Yeah. Just slap that puppy back on the pan.
So I mean, if you're cooking a steak on like a grill or a griddle, not sous vide, you're kind of doing. You're using like the high heat of the pan to do two things at once. One, bring the interior of the steak to your desired doneness, which might be like 130 Fahrenheit, something like that. But then also create flavor on the outside of the steak by bringing it to a much higher temperature than that and hoping that not too much heat leaks into the center. So you've got to kind of like time it so that the inside and the outside are the way that you want it.
Notice how she said 135 degrees
Fahrenheit.
Specifying her units of measure here.
As opposed to the vaporizing 135 degrees Celsius.
Yeah.
So Arielle, when I grew up, no one seemed to fear the idea of artificial flavoring in foods. We just viewed that as science, making things easier and faster and more profitable. And now, of course, it'd be highly objectionable to most people. What does the industry of artificial flavors look like today?
Yeah, no, I mean, there's still a huge flavor industry. It's, multi-billion dollar a year industry.
I was pissed off last time I bought truffle oil, only to find out that it was artificially flavored.
There's no truffle in the oil, baby.
No truffle. And then usually, something like a truffle will have dozens or hundreds of different flavor molecules in its flavor profile. And usually for something like truffle oil, they'll pick like the one that smells most strongly of truffle.
See, I'm blaming you for this because you could have stopped them. You could have called me right at the minute I was buying that product.
Why didn't you text me, Neil? Like,
sort of folding back into what we were discussing just a little bit earlier about the environmental, psychological effects on flavor and taste. Why is it that foods that are bad for us taste better than foods that are good for us? Because that doesn't seem to be us evolving well to defend ourselves.
Yeah, well, I mean, I don't think that's necessarily universally true because I've had, beautiful, delicious vegetables and fruits and things that are, quote unquote, natural and great for you.
Tell that to a 5-year-old.
Arielle, we have to discount the whole interview because we know you're lying.
I mean, I love a Dorito as much as the next girl, but yeah. I mean, even in food science, deliciousness is not really like a quantifiable feature. Palatability is. So, we'll often talk about highly processed foods with a lot of flavor added as being highly palatable. So, it's not so much that it is the most delicious thing that can be achieved, but that people tend to enjoy it and eat a lot of it. So, yeah, on the one side, you've got this feature of that, processed, shelf-stable, or long storing foods are much more profitable than fresh ones, and so there's a lot of money put into making them as palatable and sensorially interesting as possible. On the other hand, you've got agronomy and plant breeding and agriculture. For the whole 20th century, we've basically been breeding all of our fruits and vegetables to be, higher and higher yielding, grow faster, grow more uniformly.
And prettiness, they got to be pretty too.
Exactly.
We don't want no ugly fruit.
Yeah.
No. And, if you compare an heirloom tomato that's sort of like bulbous and novelty to a perfect supermarket tomato, one is definitely easier to look at than the other. But yeah, I mean, essentially a huge amount of time and money has been spent into basically optimizing everything except flavor in plants and ingredients.
Like if you look at just corn, if you look at corn from 200 years ago, you will not recognize it. It just doesn't look.
Go back to caveman days. There were these tiny little corn stalks.
Teosint, the original ancestral corn.
No, yeah, right. So, Arielle, before we turn this over to our Q&A section with our Patreon supporters, because we told them we were going to talk to you.
Nice. And
questions just flowed in like rivers. Just give us a quick overview of your book, Flavorama, and who published it?
HarperCollins.
HarperCollins.
Harvest division of HarperCollins. It's really giving you the lay of the land and the tools that you need to understand the science of flavor well enough to improvise with it. So I think a lot of science books about food can take a kind of like bossy tone of like, well, this is the right thing to do, or oh, this is correct. And I think with cooking, what you love, what you find delicious is really up to you. So I'd rather give people the tools to figure out how to achieve that easily.
Love the idea. Right. So this should be in everyone's kitchen, is what you're saying.
I think so. I think it will help.
She's definitely saying that. She is definitely saying that. That without a doubt. She's like, not only your kitchen, it should be in every kitchen of every person you know.
Buy it for your friends.
Right.
I spending time working with chefs in different restaurants who were like really skilled at what they do, but like didn't have a background in science. I found myself explaining a lot of the same concepts over and over again and saying like, oh, I wish I could give you a book.
That's the surest force operating on book writing.
That's how it happened.
Let's pivot this to our Q&A.
Okay, so seeing as Noma is in a Scandinavian country, let's visit that particular region. Frederick Johansson, hello, doctors and lords, for those who wish to be appropriately titled. Frederick from northern Sweden here. Famous dish in Sweden is surströmming. It's fermented stinky herring. When I was younger, I hated the smell and taste, but after trying it over the years, I today believe it's the most delicious food in the world.
Well, that's quite a turnaround.
Yeah. How can someone's perception change so drastically? Is there then an evolution in our tastes and flavors developing over our years as we age?
Yeah, absolutely. So I guess surströmming is a pretty extreme example. For those who haven't tasted it before, it comes in a can that's sort of bulging because of all the fermentation gases. It looks like a bad idea.
Listening.
It sounds explosive. She's opening it and you throw it.
No, it's recommended not to open it inside because when you put the can opener through, you can emit a jet of concentrated juices. So yeah, it's just getting the food is an extreme sport.
There's a health warning on the can.
Yeah.
I think so. I've been around a can. I haven't tasted it myself because it was really too much for me. Which I guess I need to remedy now that I'm braver than I was then.
Yeah.
But so surströmming, I've heard the tastes compared to dirty diapers.
Okay.
It's really an intense experience. But there are other things that most people don't enjoy when they first try them. They come to love. I used to work with someone whose favorite T-shirt said, "What's that smell? It's either bad meat or good cheese." So there are processes, especially in the fermented foods, that microbes can do.
In the American South, a food that resembles this story arc is chitlins, right? This pig intestines. Boiled for half a day, but seasoned.
Yeah,
and
that's and I will never eat it. And my mother used to make it all the time. My grandmother made it, and I called it slave food because that's what it is. And I was like, I'm not eating it. You know why? Because if a pig came into your house and took a dump in your kitchen, that is what chitlins smell like.
Well,
okay?
That's what
Yeah, no way.
Poop.
I mean, you literally are eating something that smells like literal poop. It's ridiculous.
Say it's some of the best food they've ever had in their life. It mirrors this example here.
Yeah, you know why? In both cases, here's why. Because at some point, your brain capitulates and accepts the abuse that is being heaped upon you. So in Frederick's case, this is just kind of like a stinky fish Stockholm syndrome. At some point he's just like, this is actually good because, all those years of abuse as a child being made to eat it finally caught up with him. That's, yeah.
Okay, you get that off your chest?
Yeah.
Like the confession here for Chuck.
I mean, so yes, those are two excellent examples of acquired taste. But then, I mean, even something like a strongly flavored cheese, like a Camembert or a Limburger, if you compare that to milk, it's horrifying. It's like, well, milk should not smell like that. But then, we're basically built as humans to be skeptical of new things. But then once we eat something a few times and don't get sick and kind of record that sense memory as a positive one, we can develop a taste for just about anything, actually.
And Arielle, the day I knew I was grown up was the first day I realized I liked blue cheese.
There you go.
I said, I'm grown up now.
That's I remember at one point I was 18 and I got a sudden craving for olives, despite having hated olives every other time I tasted it.
Right?
Yeah, they're bitter, they're pungent. So
not when you start drinking martinis at 12. That's all I'm saying.
Okay. I keep going. Who's next up?
All right,
go ahead,
Bamba from North Vancouver. Please visit. Is it possible to genetically make vegetables taste more appealing, like a chocolate flavor or Oreo flavor? Yes, I am Canadian, so put the letter U, some words, because U matters. That's how we see it.
Yeah, well, so I have friends that are, synthetic biologists that do exactly this. Not so much with vegetables, but it is definitely possible to, most since flavor is molecules.
But I just have to clarify here. Nowadays, when we refer to someone as a synthetic biologist, they're freaking making life, right? They're genetically modifying organisms. But the GMO got a bad word in recent decades.
Yeah, exactly.
So you found another thing to call them. So it's not that the biologist themselves are synthetic. They're real, but they're making synthetic food types.
Yeah, well, I mean, one famous example, and I think this is actually in use in the flavor industry, is that once you figure out the kind of enzymatic pathway that's a plant like vanilla or rose uses to make one of its flavor or smell molecules, people have tried, inserting those genes into a yeast and making a fermentation that's kind of like brewing beer, actually, but the end result is a lot of flavor molecules.
From the beginning, not added later. So
Exactly. So you basically brew up vanilla flavor and then purify it out of the sort of yeast soup. In theory, that's possible. I do know quite a few people. I mean, going back to our earlier conversation about how all the flavor has been bred out of vegetables. So when people say like tomatoes don't taste like tomatoes when I was a kid, like it's literally true. Most commercially available fruits and vegetables have very little flavor compared to 50 years ago. There are people that are interested in changing that. I have some friends at Washington State University that have a bread lab. So they breed wheat.
Is that St. Louis?
WSU in north of Seattle. So it
would be in Washington State, wouldn't it? I was thinking of Washington University.
Washington University, yeah, is in St. Louis. Yeah, so there are like academic wheat breeders and vegetable breeders that's up until maybe 10 or 15 years ago would have been making these terrible supermarket varieties that are like high yielding, et cetera, that have kind of gone rogue and are really interested in making seeds for fruits and vegetables that express a lot of flavor and are easier to grow maybe than heirloom seeds, which is what people have traditionally tried to use if they want like a really delicious tomato or wheat.
No, I don't know if we have time to go here, but I heard, and it made sense to me, that the reason why children don't like vegetables, but as adults we're either neutral to them or come to like them, children don't like vegetables because vegetables on average are bitter. And most poisons in nature are bitter. And poisons are much more potent on a small body, such as an infant or child or toddler, than they are on an adult. So that this was an evolutionary resistance to not dying by eating something that was poisonous.
Wow.
Yeah, no, that's exactly how it works. Children also, babies and children have more taste buds than adults. So we're, born with a lot of taste buds that we sort of gradually lose over our lifetimes. So, everything they're tasting is more intense than what an adult will taste.
So I can imagine a whole new TV show where children who can't otherwise speak yet, you just hear their thoughts. Stop shoving this down my throat. I can taste this and you can't because you're old. But I could picture the whole dialogue.
Yeah. Yeah, well, I mean, our tastes and our like enjoyment of tastes is like pretty hardwired. So like babies are born liking sweet foods, liking umami, being very like disgusted and aversive towards bitter. And
breast milk is sweet. So
Very sweet.
Yeah, it is sweet. Yeah.
Right.
So
Sweeter than regular than what we think of as regular milk.
Yeah, cow milk. Yeah, good source of calories and
so
energy.
Human breast milk, because all mammals would have breast. So
this is true. It's in the name.
So next up, give me another question here.
All right. Alikan Hemraj says, hello, Dr. Tyson, Lord Chuck, Dr. Johnson, Gary. My question is, how is molecular gastronomy change the way we eat in the future? Is everything just going to taste like chicken? Where'd that come from anyway? Tastes like chicken.
Yeah, I think not to harp on about the destruction of flavor in the 20th century, but if you eat an heirloom chicken or a wild chicken, it has a very intense flavor. So the kind of blandness of current chicken is a relatively new phenomenon. So maybe it will taste like chicken, but taste like the chicken of the 19th century or the red jungle fowl.
Arielle, what does chicken taste like? I'm sorry.
That's a good question.
That's a deeper question than any of us ever expected it would be.
Yeah.
Molecular gastronomy. This is thinking about food and cooking on a molecular level rather than just on a macroscopic level.
Yeah.
So do you see a trend line here in the future?
Yeah, I mean, so you've got like large food companies paying, more and more attention to flavor, especially as they're making, plant-based meats and things like this. But I think the other people working on food, whether that's farmers, seed breeders, chefs, are finding a lot of different ways that understanding the molecular side of things helps them do what they need to do. So yeah, no, I think it's going to change the way we eat in so many different ways that there's not going to be like one particular trend. And if you don't
But in
like,
the end, chicken will always taste like chicken. Okay.
Whichever side of the road it's on.
exactly.
Right, next question. Renee A. Chen. Hello, everyone from Silver Spring, Maryland. When we ultimately inhabit the moon, how will cooking differ? Will the boiling and freezing points of water change? Will food cook faster or slower? Will we need special equipment?
I can handle this, Arielle, if we...
No, I think you actually have more experience with this than I do.
Yeah, sure. So if you have a HAB module, presumably it's pressurized. And if it's pressurized, then everything is normal. The boiling points are normal. As we discussed earlier, the pressure of air or of an atmosphere on top of the liquid affects what evaporates and what doesn't, and at what temperature. So now the fact that there's lower gravity, I don't know that gravity matters much, Arielle, in food preparations. What do you think?
I don't know for cooking. I know that for people that have been trying to research growing food in microgravity, water has such high surface tension that it's sticky in a way that most plants are not used to dealing with. So in terms of growing food, definitely. In terms of cooking, probably not so much.
Probably not so much. But I can tell you this, with a lower gravity, honey will never pour out of its... If you're waiting for the ketchup to come out of the ketchup bottle. So I think, yeah, that'll be quite frustrating. But if they don't pressurize the cabin, that's the old running joke. The restaurants on the moon would all be fascinating, but they'd have no atmosphere. Yeah.
Well, I guess you wouldn't have barbecue outside, would you, on the moon?
Well, you could have barbecue, provided your source of heat does not require oxygen.
Yeah. So
No
there's
flame.
hard to get all those smoke flavors from wood without mixing some oxygen in. So.
Yeah. Okay. One more. Let's see if we get one more in here.
Willest74. Hello, doctors and comedic lord. Will from Hawaii here. In the movie The Matrix, they were discussing if machines have gotten the flavors wrong, to which Dozer replies, it's a single-cell protein combined with synthetic aminos, vitamins, and minerals. Everything the body needs. What do you think about getting the flavor wrong? If food is made up of certain chemicals and combinations thereof, will food taste the same to everyone who has the same similar receptors, or is this more philosophical versus scientific perspective, like when determining how red is the red one sees, if red at all?
Yeah, well, one of the reasons that the science of flavor is not more well known in the public is we didn't really have the instruments sensitive enough to tell what was making flavor until the last 40 years or so. And there's been papers in the last 10 to 15 years kind of identifying completely new natural flavor molecules that we just had no idea about because they were in such infinitesimally tiny amounts that a gas chromatograph mass spectrometer couldn't sense it, but our nose could sense it. So, I mean, provided that you have perfect data and then could access all of those chemicals, in theory, it's definitely possible. But it's something that, practically is a bit tricky.
What I think the Matrix got wrong there, it assumed that the flavor was something separate and distinct from the molecular structure of what you were eating. But if you've reproduced the molecular structure of it all, it should have the flavors that it would have in the authentic version of itself. So I think they got that wrong.
And, there's experience in eating where, we have things like glutamate receptors in our intestines. So that doesn't create the sensation of umami, but the experience of eating is kind of shaped by chemistry even after we swallow.
Yeah, you have sugar receptors in your gut as well. So
exactly.
It prepares your brain to receive the signal that, hey, I'm eating sugar. This is great. Yeah.
Gary, we got time for one last question. What do you have for me?
All right, here we go. Bruce Ryan. Hi, gents. And of course, Arielle. He's from Alexandria in Virginia. I always wondered why carbon dioxide sticks to water to make fizzy drinks. Do other gases work the same way? If so, why don't people make fizzy drinks with helium? Thanks for all you do. Well, you're welcome, sir.
Yeah.
Now,
That's
that would be
pretty
fun,
funny.
huh?
No, yeah,
Yeah.
don't.
So carbon dioxide sticks to water because gases are able to dissolve in water, and all gases, I think, are able to dissolve in water. Beer gas. So if you're setting up a tap system at your restaurant and using gas to dispense it, is usually a mixture of carbon dioxide and nitrogen or nitrous oxide. Depending on what beer you're pouring, you'll use like a slightly different ratio. So that like really creamy head on a Guinness is often because there's like a lot more nitrous oxide in the gas. But of course, carbon dioxide and nitrous oxide have different flavors. Nitrous oxide is kind of creamy. It's got that sort of like whipped cream smell a little bit.
Well, I thought that was laughing gas. Isn't that nitrous oxide laughing gas?
Yes.
Am I
Yes.
misremembering
So there are also recreational uses for whipped cream
Mm-hmm.
devices.
Whippets, or maybe, I don't know.
Yes, exactly.
Uh-huh.
But carbon dioxide is special because it has a prickly flavor. And we're not actually sure yet what that mechanism is, whether we have a distinct carbonation taste sensor or if it's interacting in a special way with our sour receptor.
You tell me dissolved helium wouldn't have a prickly sensation on your tongue?
Probably not. And you consider like a human's experience with carbon dioxide. Usually if you're breathing in a lot of carbon dioxide, you're in a lot of danger because you're about to suffocate. So, our suffocation reflex is actually from like high carbon dioxide as opposed to like low oxygen. So it's a little bit masochistic, I guess, that we like to, just microdose on suffocation.
Look at that. Pepsi, it's your new autoerotic asphyxiation.
Flirting with
There you
danger. Yeah.
Who would have thought? All right, we got to end it there, guys. Arielle, thanks for coming back onto StarTalk. I mean, we should have you more often.
Yeah, it's a lot of fun.
Yeah, I'd love to. Just let me know.
There's like 10 other subjects I wanted to cover, and there wasn't any time, and we went over anyway. Actually, we just learned you are a resident in the city, so you come by my office, and we could totally make this maybe a regular thing.
Amazing.
On the food spectrum.
I would
Right.
love that.
Yeah.
And next time we'll do it with the taste test.
Oh, yeah.
Bring some of your damn food that you worked on.
I will run so many tests on you guys. It'll be
No, that's
great
not
fun.
what we said. We didn't say that.
You have to take the test and then we can eat
All
some fun
right.
things. Yeah.
All right, Arielle, delighted to have you back on, and watch out for her book, which hit the stands just a few months ago.
Flavorama.
Flavorama. Yes.
Thank you so much.
Give me the full subtitle of that book.
Oh, a guide to unlocking the art and science of flavor.
I love it. When you put art and science in the same sentence, you know it's going to be good. All right, Gary, good to have you. Chuck,
Pleasure, Neil.
always good to have you there. This has been StarTalk Special Edition. As always, I bid you to keep looking up.